Bismillahirrahmanirrahim. Welcome everybody and Assalamu alaikum. We are going to start our lecture number 18 and that is about CPM and PERT scheduling. But before we move towards these very important topics, we will have a summary of the previous lecture. The other day we had talked about a little bit on WBS. As far as time management is concerned, we have used this WBS while we were actually estimating for the costs, and then we had prepared the budget. But for these two sessions, we are actually focusing on time part of perspective of the project. So then we had discussed again about 7 processes of time management, and then we have discussed about activity definition and then the activity sequencing. And today we will move forward and we will discuss another 3 processes in this very session, and there is last one process, that is schedule control, will be discussed in upcoming sessions. Then we had discussed about the relationship types. There are 4 types of relationship and then we had talked about network diagrams. Network diagrams are the preferred way to show the relationship between the activities of the project, and there are 2 types or format available, and those are activity on arrow method and activity on node method. We've done a few examples, and I have given you one good case study to be completed by your own self. Now let's start with today's lecture. So this slide has already been included in previous lecture, and as you can see, we had talked about plan, schedule, management process, and define activities and sequence activities part of time management processes. Now we will move ahead and we will talk about estimate activity resources, and then estimate activity durations. By doing those 2 steps, we will be able to complete develop schedule, and then there comes when the schedule is developed and the planning phase is kind of first iteration is completed, kickoff meeting has been held by the project team. And then we move into the execution and the implementation of the project plan, and by that time we are actually carry out this monitoring and control processes, and in that phase of the project management life cycle we do control schedule, and this will be done in upcoming sessions, but we will be focusing on estimate activity requirements and estimate activity duration. So resource estimation. Before estimating activity duration, you must have a very good idea of the quantity, quality, type of the resources that will be assigned to each activity. And consider important issues in estimating resources and what these may be. How difficult will it be to complete specific activities on the project? What is the organization's history in doing similar activities? Are the required resources available? Now that is very important. Let's say we have to construct this wall of brick, and we do know that we have to construct this wall, and total number of bricks which are required needs to be calculated. Okay, so let's say we have this length. So this is the length, let's say, and we are having like 20 feet is the length, and then we have to construct this wall of, let's say 8 feet, let's say. And we are constructing this. Obviously we can do that stuff with more statics, you know. Okay, so let's say the wall is about 20 feet and the height is about, let's say, 8 feet. Now we are having this area, and now another thing which we are in need of is the thickness, like whether we want to have 9-inch wall or 4.5-inch wall or 13-inch wall. So let's say we are having standard 9-inch, the standard length of brick is 9-inch, okay? So let's say we are using that thing, and 9-inch is the, so 9-inch is equal to, that is 3 by 4 feet, and now we have 3 dimensions. If we multiply each of these with each other, we get the volume, okay? So we are having length, we are having height, and we are having the thickness. So we are having very good idea of the total quantity. But the quantity is in cubic meter, okay? And now we are having empirical relationships between the volumes and the number of bricks. So in this fashion, we can calculate how many bricks we are in need of. So number of bricks through this procedure we have calculated, like, let's say we have calculated 3600 bricks. So besides constructing this brick masonry wall, we are in need of bricks, but again we are also in need of the mortar for binding, you know. So then we are in need of mortar. Mortar is made of cement, and there is sand, and there is water, okay? So these are 3 materials we are in need of. And how much cement is needed, how much mortar is needed, how much water is needed, similar fashion we can calculate through empirical studies and standards, okay? And then there are machines required, like mixer to mix the cement with sand and get the mortar. So we are in need of machine, and that is mixer. Now we are having this stuff with us, and then we are in need of resources, I mean human resource, like masons, labor, and supervisor. So these are few resources we are in need of while we are constructing this wall. So you see, we are doing this part of definition, type of resources over there, and the quantity, let's say we have calculated the quantity of bricks, okay? Now there is very important part. We are available with one mason with our company, and we have these standards that one mason can actually plant 1200, about 1250 or 1200 average bricks in one day. So how many masons we are in need of? Then we are having 3600 bricks. We are having one mason. One mason can plant or lay 1200 bricks in one day. So one mason can complete this activity in 3 days. So this is how we actually estimate resources, quantify, and there is the relationship between the number of resources and the time duration of an activity. Now let's move towards this process, and that is activity duration estimation. Duration, what is the definition of duration? Now that is very good concept we should be having. Duration is, it includes the actual time needed to complete the work on an activity plus the elapsed time, okay? So the duration is whatever we are actually doing on some activity plus whatever the time we require to make some, you know, have some cushion for the labor or stuff like that. Okay, and then effort. Effort is the number of exactly the number of work periods or work hours or work days or work weeks or work months required to complete a task. Okay, so there is an activity of laying of these bricks, and we are having one mason, and one mason does lay 1200 bricks. Okay, and there are total 3600 bricks. How many days will this mason take to lay these 3600? So in one day he will do 1200, next day 2400, 1200, 1200, 2400, and the third day he will complete the task. So the effort of the mason is equal to 3 days. But the activity may take up to 4 or 5 or 6 days. And why is that? So this part is 3 days, and that is effort. Now what is this? This is elapsed time. You have to cure it. The mason is gone, the brick has been erected, but you are actually curing it. You are putting water on that so that can be cured, and all the cement can get the strength, due strength. So this part is not the effort part. The mason has already been gone. And this activity is taking this much as a lapse time. You have to leave the completed work for a few days so that you can move ahead or something like that. Okay, so similarly, while a computer programmer is writing a code, and he's written or she's written a code of like 1 lakh lines, and the effort needed for writing this type of work is like 6 months, and the effort needed for writing code lines of let's say 100,000 is 6 months. But after writing that code, there is an approval procedure that this engineer will submit the code to somebody in senior position, and he or she may actually have validated the code, and hence he or she may take another week or 2 or month to validate that. Now the activity duration will be 7 months, then 6 months for code writing, the effort, and 1 month is just for lapse time. So this is the difference between the duration and effort. So both things should not be confused. So effort usually does not equal duration, and people doing the work should help create estimates, and an expert should review them. So activity duration estimation is very tricky part. As far as engineering projects are concerned, many things have been so matured over the years, over the decades, and even centuries. People do have their efficiency trends and stuff like that. They can actually estimate the duration very accurately because they do have a lot of data. But when it comes to social projects or R&D projects, things get better tricky, a little bit tricky, and then we are in need of some other type of methodologies to have activity durations. We will go through that part of presentation. And after having all these activities through activity definition, and then relationships through and diagrams through activity sequence, and then estimation of the resources, and then based on these resources we do have estimation of durations, and then we come to the point where we can develop this schedule thing. So it uses results of the other time manual processes to determine the start and end dates of the project. Okay, ultimate goal is to create a realistic project schedule that provides a basis for monitoring project progress for the time dimension of the project. Important tools and techniques include Gantt charts, critical path analysis, critical change scheduling, and PERT analysis. Now we are having this one thing over there, and that is Gantt chart. Gantt chart was developed by this engineer scientist, and his name was Gantt, and that is nothing else but a bar chart, horizontal bar chart. Rather, it is a vertical bar chart, it is a horizontal bar chart. So over there we are having activities, and over there this axis is time axis. Okay, so this is time axis. Over there you can see August 12, and over there May 13. Okay, so if we have this excavation part, so this length of over there of the bar actually represents the duration of this particular activity, excavation. Okay, so and this bar is actually showing up the duration of this activity, foundations. Okay, so and similarly we are having relationships. So this activity will start when this activity finishes. So this activity is dependent on this activity. This activity is dependent on both this and this activity. Okay, so this is one way to show the relationship, and the total duration of the project is given over there. And the bars which are shown over there in red are on critical path, whereas bars on blue are actually normal or non-critical activities, and then non-critical path activities. Okay, so there is a difference between critical activities and critical path activities, and then these bars are summary bars. Now this bar is showing this work package, finishing works, and these are activities. So this is the summary bar of all these bars, and actually is getting to that point. Now this is civil works, summary bar, and this is for finishing works, and over there we can have this total construction. So project duration may be of that much. Okay, so this Gantt chart is used for a very good schedule development. And another tools which we may have are critical path method, one of the very good tool. So critical path method is a network diagramming technique used to predict total duration of the project. Okay, so critical path method is nothing else but it gives total duration of the project. So I have asked so many times from so many people and different audiences, and what I have come to know is longest path, shortest duration possible, and stuff like that. But the simple straightforward answer is critical path method gives you the total duration of the project. And the other definitions are right, but we should speak plainly when it is been asked. Okay, so a critical path for project is series of activities that determine the earliest time by which the project can be completed. Okay? Earliest time by which is the probable duration. Okay, so the critical path is the longest path through the network diagram and has the least amount of slack or float. And slack and float, what are these? So slack and float is the amount of time and activity can be delayed without delaying a succeeding activity or the project finish date. We are going through these definitions in detail in relevant slides of this very course. Okay, and in 57 the critical path method was developed as a network model for project management. CPM is a deterministic method that uses a fixed time estimates for each activity. And while CPM is very easy to understand and use, it does not consider the time variations that can have a great impact on the completion time of a complex project. So for that thing we do use another tool, so that is called PERT, but we are so calculating the critical path. The steps are very straightforward, very simple. We will have one or two good examples by using both the activity on arrow and activity on node, and the first step is develop a good network diagram, logical good network diagram. So we are in need of that thing. Then add the duration estimates for all activities on each path through the network diagram. The longest path is the critical path. If one or more of the activities on critical path takes longer than planned, the whole project schedule will slip unless the project manager takes corrective action. So critical path is important because you cannot delay anything. Okay, so let's have a very good example over there. Okay, so we were having this activity A and B and C, and these three activities are dependent on nothing. I mean, they start the project. Okay, so we are having this node number 1, and remember we were developing this thing in previous class. Okay, so activity A, B and C, these are not dependent on any activity, so these are independent activity, but activity D is dependent on activity A, and E is dependent on activity B, F is dependent on activity B, and G is dependent on activity C, and then H is dependent on D and E, and G is dependent on H, F and I is dependent on G, and G is dependent on C. So we have developed this diagram. Now another thing which we didn't discuss the other day was this part. Now what is that? I have talked of that, but now let's talk in a bit detail. These are the durations, and duration of what? Duration of the activities, and from where these values are coming from. Remember, the first part of process of time management is activity definition. A, B, C, and they are actually dependent on, D is dependent on A, E is dependent on B, activity attributes, and then we had this network diagram through sequence activities, precedence network diagram method. Okay, so and this is a preferred way to show the relationships. Okay, so we are having all these activities, and they are dependent on relevant activities, but we have completed one process of define activities, and then we had A, B, C, D, E, F, G, H, whatever, how many number is there. Okay, so the second thing we've done is we have these relationships between the activities and the activity definition, and then we have developed one very good network diagram through activity sequence activities, and then there comes the part we were discussing the earlier. Okay, and that was estimate activity resources, and we had a very good estimate of resources, a very good example of the bricklaying. Okay, and then we had estimate of activity duration. Now from that activity duration, or through that process, we have come to this table. Okay, so if I develop this table, let's say very plain and straightforward, for one project X, and I have this WBS with me. Okay, let's say we are having a WBS as well, and okay, so through that WBS I have defined my activities, and I do know that I have like 4 or 5 activities, and activity A, B, C, D and E, these are identifiers. And now activity description, like this is found excavation and blah blah blah, complete description of that. And then B is like foundations, and C is superstructure, and then is roofing, and then is flooring. Let's say very very broad. So description, identifiers, number, serial number, identifiers, and description of the activities. And then there are relationships, okay. So A is dependent on nothing, B is dependent on A, C is dependent on A and B, and D is dependent on let's say B, and E is dependent on that is B and C, and E is dependent on B. Okay, so let's say we are having these dependencies, and these are kind of discretionary at times, and project team actually decide which activity is dependent on which other activity. Okay, and then we have these processes of resource requirement. So we have this column of resources, and we can write resources for resource number 1, 2, 3, 4, 5, whatever number we have. So we actually fill this column for every activity. Based on those resources, we have this one last column, and that is time duration. Okay, having these resources, these are requirements, and we are having this this much resources, this will be the time. Okay, so based on that, we have come to this point where we can actually draw a very good network diagram up to based on information up to that point. Okay, but then we have put number 1, 2, 3, 4, 5, whatever the numbers which are actually depicting the durations. Then we are having these numbers from that very table. Okay, so now we are having those numbers with us. What we have to do is we have to identify different paths. Okay, so if I start from 1 and I have to reach to 8, how many different ways I have? So if I start from 1 and then move towards 2, 1 to 2, 2 to 5, 5 to 6, and 6 to 8. Okay, so my path will be 1 to 2, activity A, D, H, J. So this is my path. Okay, this is one path I'm following. Okay, so this is one path. So activities falling in that path are A, D, H, J, A, D, H, J. Okay, and then second path is there. Okay, the second path. So 1, 3, 5, 6, 7. So the activities in that path are B, E, H, J, B, E, H, J. Okay, and then there is another path, very straightforward. So B, F, J, B, F, J, and then the fourth path is there, C, G, I, J, C, G, I, J. So in this fashion, I have identified all the paths, C, G, I, J. Now write the duration of respective activities and sum them up. Okay, the duration of A is 1, D is 4, and H is 6, and the duration of J is 3. So I write 1 plus 4 and 6 and 3. So I'm having 1 plus 4 plus 6 plus 3, and that is 14 days. Okay, and similarly we are having this path BEHJ. So length is 16 days total length, and similarly we are having the durations of other paths as well. Now what is the longest duration we are having? We cannot complete the project before that duration, and that is 16 days. We cannot complete our project before 16 days because that is given over there. So until unless we do use some other methodologies like crashing or stuff like that, but we are not going to talk at this moment. So longest path is the critical path. Okay, so if we want to bring our project to shorter duration than 16, like 15, so what will we have to do is we have to reduce the duration on critical paths to bring it back. So that is the duration of the project as well. 16 days is the project of the duration. Now there is very important part and very important point which many participants actually miss, and that is completing the critical path activities does not mean that you have completed the project. Okay, you have to, this is not like we are having B, E, H. So this is our critical path. So this is our critical path. Let's raise stuff a little bit. Okay, so many a time people used to do that stuff. They think that if we are actually doing this critical path stuff, and we are completing the activities on critical path, we are equally available and able to complete our project. No. So if you are having this critical path, right, B, E, H, that does not mean that you are completing B, E, H, J and your project is finished. No, you have to also complete these activities as well, which are not on critical path, right? So the critical path is time related. Okay, for the sake of completion of the project, you also need to complete other activities as well, and this is the one which is having least flexibility as far as time is concerned. So this path can be delayed by 2 days. Okay, 14, because your total duration is 16 days, and this path will take 14 days. But what if that path takes 17 days? Now this path has turned to be the critical path rather this one. Okay, now so you have to keep a good eye on non-critical paths as well. The critical path is very good indication if your project is going good, but you cannot delay the project on non-critical paths. This path may have the slack or float. The other time we were talking about 16 minus 9, and that is 7. So 7 days. What if you have delayed these activities up to 6 days? Very fine. These one activity or few activities on this path have been delayed up to 5 days. Good. 7 days. Good. 8 days not good, because now this path has BFJ has turned to the critical path. So many people do make this mistake. So I will advise you to not to fall into that. And another very important thing, this is very important part, and people usually get confused. It is not always necessarily mean कि आपकी जो critical activity है वो critical path के ऊपर हो. So critical path activities is something else and critical activity is something else. Okay, so this is another very good okay. So using CPM to shorten a project schedule, we were talking about there are a few methods. So there are techniques available, and one technique is shortening the duration of the critical activities or task by adding more resources or changing their scope. So critical path activities. So three main techniques. उसमें सबसे पहले ये है कि आप जो क्रिटिकल पाथ के ऊपर एक्टिविटीज़ हैं उनकी ड्यूरेशन को कम कर दें बाय एडिंग सम मोर रिसोर्सेज. क्रैशिंग एक्टिविटीज़ बाय ऑब्टेनिंग द ग्रेटेस्ट अमाउंट ऑफ शेड्यूल कंप्रेशन फॉर द लीस्ट इंक्रीमेंटल कॉस्ट. सो क्रैशिंग के अंदर आप क्या करते हैं कि आप रिसोर्सेज ऐड करते हैं और उससे फास्ट ट्रैकिंग activities by doing them in parallel or overlapping them. So जो आपकी critical path की activities हैं बजाय उनको आप sequence में करने के आप उनको parallel कर लें. So in that fashion we can do that. याद रखें resources क्योंकि इसमें नहीं लगे, इसके अंदर सिर्फ आपने sequence change किया है. So fast tracking जो है इसमें पैसे इस तरह नहीं लगते, जिस crashing के अंदर आपको cost include करनी होती है. So the critical part does not necessarily contain all the critical activities. It only accounts for time there can be more than one critical path if the lengths of two or more paths are the same. Yes, that can be possible. The critical path can change as the project progresses. So we had talked about these concepts. Okay, let's have this example, and we will be doing this stuff with activity on arrow type of method. Okay, so first step is to draw a very good network diagram. So A and B are dependent on nothing. So first thing is we will develop this node, and A and B are dependent on nothing, and then C is dependent on A and D is dependent on B. So A activity is dependent on, so C is dependent on A. So this is activity C, and D is dependent on B, and D is dependent on B, and F is dependent on B, and F is dependent on, and then there is a activity E which is dependent on D and F. So we introduce this dummy activity, and there is activity E, and we have done A activity B, C, D, E, F, and G is dependent on C, and then we are having, let's say this is E, okay, and we are having this activity G, so okay, so this is activity G, and then activity H is dependent on G and E, okay, G, E and G, okay. So we have developed our network diagram, and now we are having durations. So what we will do, we will write the durations over there. So A is 7, B is 3, C is 6, D is 3, and E is 3, and F is 2, okay, and G is 3 and 2, H is 2. Now what is the duration of this dummy activity? What is the duration of that? If your answer is 0, good. So this is having 0 duration, okay. Now how many paths we have? Okay, let's see. The first path is A, C. Okay, let's write numbers as well. 4, 5, 6, 7, and 8. Okay, so let's say first path is A, C, G, H. So we have to start from 1, and we have to reach at 8. So this is the first path, and then path number 2 is B, D, E, H, and path number 3 is B, F, dummy, and E, and H. So these are 3 possible paths through this very diagram, okay. So path number 1 is A, C, G, H. So write the durations of respective activities. So A is 7 days, C is 6 days, and G is 3 days and or weeks, whatever the work units are there. So I'm assuming days, okay. Okay, so and H is 2, then B is 3 plus D is 3 plus E is 3 plus 2, and B is 3 plus F is 2 plus dummy is 0 plus E is 3 plus H is 2, okay. Now sum these up, okay. So 7, 13, 16, and 18. So 9, 11, and 3 to 5, 5, 10. So what is the duration of your project for this very particular thing? And that is 18 days or whatever the units you have. So I'm using days. So that is, and this path is critical one, A, C, G, H, right? So in this fashion we can have a very good critical path method, and we can have the duration of our project. Now, using the critical path method concept, we can have the same thing with PDM, precedence network diagram, or activity on node diagram. So for that, the other day we had learned how to develop our activity on a node diagram. So over there you can see that box. Remember other day I was actually doing that stuff. एक बॉक्स मैं बना रहा था, उसके अंदर ये 3 ही रोज और 3 ही कॉलम्स के अंदर मैंने डिवाइड किया था. अब इसके अंदर आप इस तरह कर सकते हैं कि यहाँ हम लिख रहे थे एक्टिविटी आइडेंटिफायर. सो अभी हम उसको यूज करते हुए कैसे हमने चलना है वो लेट्स इसको देखते हैं. सो अर्ली स्टार्ट is when the activity can start at the earliest, and then early finish when the activity can finish at the earliest. So late finish, when can the activity finish at the latest, and late start, when can the activity start at the latest. And the critical path of the project is the sequence of activities that determine the project completion date. Any delay in an activity or activities comprising the critical path will delay the project by a corresponding amount of time. And the slack is the time for which the project activity can be delayed without delaying the preceding or succeeding activity, and or the duration of the project, also called as float. So some useful definitions before we move and have a CPM. So free slack or free float is the amount of time an activity can be delayed without delaying the early start of any immediately following activities. Total slack or total float is the amount of time an activity can be delayed from its early start without delaying the planned project finish date. Forward pass, backward pass, the definitions are over there. Those are not very difficult things. We are going to do that stuff. A forward pass through the network diagram determines the early start and finish dates, early finish dates, and the backward pass determines the late start and late finish dates. So let's have this exercise, and let's say this is about construction, and there are 1, 2, 3, 4, 5, 6, 7, 8 activities, and description is given over there. The relationships are given over there, and then activity durations are given over there. So now we have to develop activity on node diagram. So first of all, we will have these boxes, and then we will have descriptions, and then the relationships, and then we put the durations in that. Okay. So then we will have a forward pass. Now how these things I will try to explain. Now these things are durations, and these are from the previous slide. Okay. So durations, and remember the previous slide over there. So let's see, we are having this duration of G activity 170 work units, like days or weeks, whatever the time is there. So let's say, okay, so over there G 170, right? So these are the durations. So put durations over there after writing A, and descriptions over there, and then start with 0. Put a 0 over there. Then add this 0 with that duration, you will get this. So this is early start, and this is early finish. So early start plus duration will give you early finish. Okay. So the formula is given over there. ES, early start plus duration, is early finish. So you are starting with 0. Some people used to start with 1, but I prefer to use 0. But both the methods are quite same. If you do know the difference between, it does not make any difference over there. Then early start is 0 and 5, and then you are having early finish 5. Okay, so transfer this 5 over there, the early start of the next activity. Okay, so then by adding this early start with the duration, you are having 5 plus 15 20, then 5 plus 10 15, and 5 plus 5 10. Now this is transferring 10, this is transferring 5, and this is transferring 20. And for that activity F, which is dependent on B, C, and D, and F is actually transmitting 20, C is transmitting 15, and D is transmitting 10. What should you take then? Now there is a point of choice. You will take the highest one. Okay, so this will be rejected, this will be rejected, and this will be taken. So 20 is taken over there. And for that E activity, we are having this 20 and 15. So we will consider 20, and hence 20 plus 15 35, 20 plus 10 30, and 30 will go over there, early start of the next. 30 plus 1 70, 200 over there, and 35. Now this is sending 200 and this is sending 35. आप लेंगे 200, आपने 200 लेना है और वो यहाँ से आएगा, ये वाला 200 के अंदर 35 जमा करें तो आपके पास 235 आएगा. Now this is forward pass. Okay, what is this 235? Amazingly, that is the duration of your project. Okay, now we have done that. Forward pass is complete. Now backward pass. Okay, good. 235, shift that 235 downwards over there, and this 235 minus 35 will give you 200. This 200 will go back towards, okay, and then 200 minus 15 minus, अब हम minus कर रहे हैं duration को over there, that is given over there. Late start plus duration is late finish, but we are having late finish, so late finish minus duration is equal to late start. Okay, so 200 minus 15 is 185, and 200 minus 170 30 will go over there. Okay, now there is a point. We are having this 20, and 20 will go over there, and over there. And for that we are having, for this particular activity C, we may have 20 from that or 185 from that. Okay, what will we choose? This is backward pass. For forward pass we have chosen the highest one. For backward pass we will choose the lower one. Okay, so we will choose 20 over there. So 20 is very fine, and for that 185 will go over there or 20 will go over there. So we will choose 20, which is the least one. So we are having 20 minus 15. Okay, so these are in this fashion we get to that first activity from where we have started. Now forward pass is complete, backward pass is complete. Now we have to determine the critical path, and for that we will determine the slack, and slack is we actually subtract this value from this from this, 10 minus 5, this minus this. Okay, so if I take this example, so 10 minus 5 will give 5. Now this 5 is actually getting there. Okay, and 15 minus 5 10. If you subtract, you either select late start minus early start or late finish minus early finish. So you are having the same concept. Now the activities with the zero float are on critical path, right? So for that very example, A, B, F, G, H are on critical path, and the duration of your project is 235. So in this fashion we can complete our example of CPM. Now moving towards a more complex situation where you cannot actually identify the duration of activities with such confidence. So for that, instead of providing one single estimate for one activity, it is often helpful to create a 3-point estimate. An estimate that includes the optimistic value, most likely value, and pessimistic estimate, such as 3 weeks for the optimistic, 4 weeks for the most likely, and 5 weeks for the pessimistic estimate for only one activity. So we are having 3 values for each activity. So 3-point estimates are needed for PERT estimates and Monte Carlo simulation. We are not going to talk about Monte Carlo simulation at this point in time. We will talk this when we will be doing the risk management part of this course, and we are going to have quite a few sessions on risk management. So Monte Carlo simulation will be discussed over there. So we will be going to talk about PERT, 3-point estimation. Okay. So what is PERT? People used to PERT is program, evaluation or review technique, and project. So you can actually change program or project. These are quite interchangeable. So many people use programs, evaluation and review technique. So many people used to call it project evaluation and review technique. I use both. Okay. So PERT is a network analysis technique used to estimate project duration when there is a high degree of uncertainty about the individual activity duration estimates. PERT was developed in the late 50s for the US Navy's Polaris project. Having thousands of contractors, it has the potential to reduce both the time and cost required to complete a project. So wherever the CPM uses a deterministic model, the PERT uses the probabilistic model. And duration estimates based on using optimistic, most likely, and pessimistic estimates of activity duration or 3-point estimates. And in the critical path method, the time estimates are assumed to be known with certainty. In certain projects like research and development, new product introductions, it is difficult to estimate the time of various activities. Hence, PERT is used in such project with probabilistic method using 3 time estimates for n activity rather than a single estimate. So one is optimistic time. It is the shortest time taken to complete the activity. It means that if everything goes well, then there is more chance of completing the activity within this time. And most likely time, it is the normal time taken to complete an activity, normal time, okay, if the activity were frequently repeated under the same conditions. And pessimistic time, it is the longest time that an activity would take to complete. It is the worst time estimate that an activity would take if unexpected problems are faced. So the duration, the distribution is kind of the beta distribution. So over there you can have this, you know, the shape is just like that, okay, beta distribution. Time duration. So we are going to use this distribution. And there is a formula, and formula is very straightforward, okay. So that is optimistic time plus 4 times most likely time and pessimistic time, and then we divide it by 6. So PERT weighted average, let's say one example, if we are having optimistic value of 8 days, most likely is 10 days, and pessimistic is 24 days, then we put these values in this formula, and we are having 12 days. Hence, 12 days will be the probable duration of one activity. So different formulas are available. We have talked about the average or mean value of the activity duration by TO, TM. TM is TO is a time optimistic, time most likely, and time pessimistic, TP, and divided by 6. So this is the time of activity. TA is time of the activity. And another very important parameter which is used in PERT is variance. Okay, and variance is the standard deviation square. Okay, so what is the standard deviation? And if we put that sigma is TP pessimistic minus T optimistic divided by 6. And what is the variance? Variance is nothing else but sigma square. Okay, so the variance of the activity time is calculated using the formula which is TP minus T naught by 6, and you take the square. And then probability of the project duration, the probability of completing the project within scheduled time or contracted time may be obtained by using the standard normal deviation, where TE is the expected time of the project completion. So T is the expected time duration and summation of all the standard deviations and squaring them, and then taking under root, we are having this probability. We are going to use these formulas very shortly. In short, okay. Probability of completing the project within scheduled time is done through that formula. So probability of TS is greater than or equal to T is equal to probability of Z naught is greater than and equal to Z. So we are going to use these formulas. So do not be very much worried about these formula. These formula are very simple to use. Okay. So these are few steps in PERT planning process. First of all, identify the specific activities and milestones, activity identification or definition. Determine the proper sequence of the activity. Remember, the third process of time management process, sequence activities. Construct a network diagram. Again, we have to develop this network diagram first. Estimate the time required for each activity through that 3-point formula. Okay. Determine the critical path. Update the PERT chart. Okay, so this is our example. Let's have so this was very simple example over there, and now we are having this duration, one duration. Let's add something in that. Okay, so we are having this most likely. We make these values most likely, and we put like 5, and then we put like 10. If we put these values in relevant formula, we may have, and that is 5 plus 4 times 7 plus 10 and divided by 6. So we are having like 28, 38 and 43 by 6. And another formula is, this is the mean value. Okay, so this is the probable duration, 7.16. Okay, so that is 7.16 our probable duration, and then we are having this standard deviation is equal to pessimistic value minus optimistic. So 10 minus 5, 5 by 6, and that is 0.83, and by taking square we are having 0.83 square. So in this fashion we will have all the durations and all the variances, and how to use these we will do that example over there. And an R&D project has a list of tasks to be performed whose times estimates are given in the table as follow. Activity 1 2 1 3 1 4 2 4 3 4 3 5 4 6 4 7 5 7 6 7. Activity name is A, B, C, D, E, F, G, H, I, J. And what is the relationship? Which activity is dependent on which activity? So these are another way of showing the relationship. Okay, so if we draw one good network diagram, but before we draw the network diagram we have to find out the time. So if we use 3-point formula, 8 plus 4, so let's say we do calculate the values for that. So 8 plus 4 times 6 divided by 6, 24, 32, 36 by 6. So 6 is the duration, mean duration. And what is the variance? That is 8 minus 4 divided by 6 square, and that is 4 by 36 square, and that is 1 by 9 square, and now 1 by 81. That is the variance. In this fashion we will calculate the duration of this and variance of this. So we are in need of these two values. Okay. So what we have to do is draw the project network, find the critical path, find the probability that the project is completed in 19 days. If the probability is less than 20%, find the probability of completing it in 24 days. Okay. So example was there. So time expected for each activity is calculated using the formula, and that is over there. Okay. So we have already done that, right? Similarly, the expected time is calculated for all the activities, and the variance of each activity time is calculated using the formula, and we have done that. Similarly, the variance of all the activities are calculated. So variances are need to be calculated, and then we are in need to calculate the durations. Okay, and then so this is the final version, the table we are having. Okay, so these are the activities like A, B, C, D, E, F, G, H, I, J. Okay, so T naught, TM, TP, but then T. This is the time of activity through that 3-point formula, and this is the variance we have calculated. So these are two new columns we have added. Now, by having these durations and variance, let's draw a network diagram. Okay. If we draw it 1, 2, 1, 3, so so this is the network diagram we are having. Okay, so 1, so this is A, and then 1, 3 is B, 1, 3, this is B, and this is C. Similarly, we can add all the numbers and identifier of activities. Okay, so let's see which path is critical path. Okay, so if we add these identifying paths, let's say we identify 1, 2, 4, 6, 7. This is one path. Then there is another path that is 1, 4, 6, 7, and another path is 1, 3, 4, 7. Another path is 1, 3, 5, 7. Okay. So if we add the durations, 6 plus 2 plus 5 plus 8, and then 9 plus 5 plus 8, and then 9 plus 10, and then another path is 4 plus 7 plus 10, and then another path is 4 plus 8 plus 4. So these are few paths we have identified for them. Okay, so 8, 5, 13, 13 and 7, 20. So 8, 5, 13 and 9, 22, and 19 and 7 and 11, 10 and 11, 21, and 8, 4, 12 and 16. So our expected duration of the project is 22 from that. Okay, so we have calculated our earliest time and the latest time from that. Okay, from the network diagram, the critical path is identified 1, 4, 4, 6, 1, 1, okay, 1, 4, 4, 6, and then 6, 7. Okay, 9 plus 5, 14 and 22. This is what we have, and the duration is 22 days. Okay, so let's have this thing. Okay, then we have done this part that we have constructed our network diagram, and we have found out the durations as well through that probabilistic formula, and now we have variances with us. So the probability of completing the project within 19 days is given by this formula. To find Z naught, we have this formula, and TS is 19. We want to check the probability of 19 days, and estimated time is 22. So 19 minus 22, and the sigma of variances. If we are having variances like on critical path, there are 3 activities on critical path, and the variance on those activities are 2.777 plus 0.444 plus 1.77. So we take square root, and then we get this value minus 1.3416. So this is the value of Z naught, and we know that the probability of Z network model greater than Z is equal to 0.5 minus Z of 1.3416, and from normal tables Z 1.3416 is 0.4099. So 0.5 minus 0.4099, we are having 0.0901, and hence the probability is 9.01. Then comes the second phase. If thus the probability of completing the R&D project is 90 days, which is less than 20%. Hence another thing is we will find the probability of completing it in 24 days. So again the same thing, 24 minus 22, 2 by 5 square root, and then we are having 0.8944 days. Using same formula, so from normal tables, y 0.8944 is equal to 0.3133, so 0.5 plus 0.3133, so the probability is 81.33%. Okay. So this is about how we actually calculate the duration, but there is another thing which is important and needs to be corrected over there. Like we were having this path 958, we should not say that this project will be completed in 20 days, but we may consider giving the range. Okay, so we will say, okay, the duration is 22, probable duration, and there is a range as well. Okay, so what we will do is we will take the variance of 3 activities which are on critical path. We will add them up, and we will have like 0.5. I think we will get that if we add this activity on critical path, this activity is in critical path, and this activity is on critical path. So we add the variances 2.777, then 0.444, and then 1.777, right? So 7, 7, 14, 18, and 8, 7, 8, 12, 19, and 1, 8, 12, 19, and 3 and 4. So about 5, 4.998. So 5 under root. Okay, if we take 5 under root, that is about 2 point something. Okay, so we will say the duration of our project will be 20 days plus minus that much days. That will be the duration of your project, not exactly discrete value of 22. Okay, so that would be the probable range of that may be 22 minus or 22 plus 5. So that is the range of your duration of project. So we have completed this thing. Now we will have the benefits of PERT. Expected project completion time is achieved through that. Probability of completion before a specified date. The critical path activities that directly impact the completion time. The activities that have slack time and that can lend resources to critical path activities, activity start and end dates. Limitation of PERTs, there are few. The activity time estimates are somewhat subjective and depend on judgment. In cases where there is little experience in performing an activity, the numbers may be only a guess. In other cases, if the person or group performing the activity estimates the time, there may be bias in the estimates as well. Even if the beta distribution assumption holds, PERT assumes that the probability distribution of the project completion time is the same as that of the critical path. That is quite a different thing, because other paths can become the critical path if their associated activities are delayed. PERT consistently underestimates the expected project completion time. Time due to alternate paths becoming critical is perhaps the most serious of these issues. To overcome this limitation, Monte Carlo simulations can be performed on the network to eliminate this optimistic bias in the expected project completion time. So this is another exercise. We have done that while we were doing that, but now we have to complete this assignment for your own practice. Okay. So with that, we conclude our lecture, today's lecture, and this was kind of very demanding one, and we had talked about PERT and CPM, and we have talked about activity resource estimation and duration estimation, and I hope we have done that thing. Okay, so this is today's end note, and that is obstacles are those frightful things you see when you take your eyes off your goal. And this is said by Henry Ford, and I take your leave. I say thank you and good luck. Allah Hafiz.